Welcome to Academic Digest class. Today's class is on gravitation. So when you hear gravitation, it simply talks about the force or the effects that objects have when they move, be it higher, be it below, be it above or around the sun. So on the surface of the earth, gravity is experienced. The same thing with the moon. So it's not just about the earth, but all the planetary bodies, the effect that objects or effect that those bodies have as a result of moving around the sun is what we call gravitation. So if that be the case, this topic will have us treating the laws of gravity on earth. There are so many people that worked on this, but just as life may have it, the main person recorded is Isaac Newton. Who knows? There are other people that really worked on it, but he was popular. With the events of things today, you see that he's the popular person that takes the credit for everything. So I'll be outlining the law of gravitation. And I want you to know that this law of gravitation is simply given by, he said that force, that everything on earth or every object around the sun has a force under the sun has a force of attraction that is directly proportional to the masses m1 m2. So I will use m1 to be the mass of, let's say for example, earth. Now this one will be the mass of what is on earth, maybe you and I. And when I'm talking about the sun, the sun is bigger than the earth, so this becomes that of sun, this becomes that of earth, all over. So he said that force of attraction is directly proportional to the masses and inversely proportional to the square of their distance apart. So that means that anything I'm comparing, when I now introduce this, because F equals to introduce proportionality constant G, M all over R squared. You need to know that this G is equals to, is a constant that is equals to 6.67 times 10 raised to the power minus 11. The units, I always get the units by making G subject of the formula. So if I make G subject of the formula here, it will become that G is equals to FR squared all over M. So you can see that this is the same thing as saying kilograms square. This one is Newton. This one is meter square. So that means that this is simply Newton meter square per kilogram square. That is how I get the units. I don't try to, in fact in physics I don't try to memorize or cram anything. What I just need to know is to understand that particular topic to an extent that I know what it's talking about. From the formulas I get what I'm looking for. So if I know this, under this topic we'll be doing things like getting the mass of the earth. If you like, you can get the mass of the moon as well, getting the mass of the sun. So getting gravitational potential, getting gravitational potential energy, getting escape velocity, getting, yes, oh, did I skip anyone? So gravitational potential energy, escape velocity, okay, orbit around the sun, its density of the earth. I think I skipped one. So gravitational law, mass of the earth, mass of the sun, That is most important. Acceleration due to gravity. So let's draft all this thing out as a subtopic and treat it one after the other. So how I like to treat this course is just know that F is equals to GMM all over R square. This F, since we are talking about object, effect of an object has moving up or down or round surface of the sun or under the sun, so that means that gravity is involved. This is mg equals to gmm all over r square. So when I'm talking about the earth now, the same formula is what I'm using. So when I'm talking about the earth, it simply means that what I'm now having is, for the earth, I'm now having m. The first m is now mass of earth. This equation, comparing it with whatever I'm doing, is what's how you go about this course. Then the smaller m is mass of objects like me and you. So mass of body or objects. So comparing it, I now have mg small g equals to gm over r square. This will cancel this. So mass of the earth will now be, this will be gr square equals to gm. So making m subject of the formula, you have gr square all over g. So if you make this now, remember that g is 9.8. Radius of the earth is simply 64 kilometer. Radius of the earth is 6,400 kilometer, which is the same thing as saying 6,400 kilometer means 1,000 meter times 1,000, which is equals to 6.4 times 10 raised to power 6 meter. So that means 6.4 times 10 raised to power 6 all square divided by 6.7 times 10 raised to power minus 11. If you punch it, you have that the mass of the earth. Let's punch it. Where are you, calculator? Where are you? Wait, let me get my calculator. So I made the mistake of trying to break this down, and it's not making me have limited space. And like so, but let's go, Sean. So I now have 6.4 times 10 raised to power 6 times 6.4 times 10 raised to power 6 now times 9.8 then divided by 6.7 times 10 raised to power minus 11. So you have, just call it 1, 2, you have around 599. Let's confirm what we have here is what we have here. So I have 5 okay, that is so I have 5.997 times 10 raised to power 24 kilogram. Okay, so this is now the same thing as saying, let me write it here. I have 5.99. That is times 10 raised to power 24 kilogram. So please, I'm punching. So you punch and be sure that we are correct. So for the sun, using the same approach, but this time around m will be mass of sun, big M, while small m will be mass of earth. And we normally say that the radius of the earth, the center of the earth from the center of the sun is equal to 1.5 times 10 raised to power 11, and this should be in meter. So if I know this, I will now use the same principle, which is m, mass of earth experiencing gravity, that is equals to gm m over r square. So if that be the case, do the same thing. This cancel this, so mass of the sun will be equals to gr square all over g. So it will now be, in that case, should be 9.8. Yes, that is what they have in common, because that gravity is of the earth. So I have for the sun, but notice, yes, that's the problem I would have I could have gotten into problem. Notice that unlike human being that is just having this to face here, for earth is rotating, so what it is having is centripetal force, that is w square r, sorry, that is what is having, w square r. So that by the time you check it, if you make this should be, oh my god, why did I put myself in? Let me start this thing from here. So I have mass of the earth, that is force, everything here is force, centripetal force of the earth, because it's rotating, is equals to gmm over r square. This will cancel this, so that I now have w square r equals to gm over r square. This can cancel this, so that I now have sorry, before I cancel, what am I trying to work on? I'm trying to make this subject of formula. This should be m equals to w square r times r square. What am I doing? All over g, so that m will be equals to w square r cube all over g. Now notice, remember that w square itself, m is equals to w square, that is from this thing, this is displacement, and angular velocity is equals to displacement over time, and this is the same thing as saying theta is the same thing as saying 180, sorry, yes, 180, yes, so 180 degrees times 2, that should be theta, and degree, so 2 pi is the same thing as this theta, so all over t. And notice this is the same thing as that thing I normally say, 2 pi times 1 over t. Everything here is f, 2 pi f, so this is the one we are using. So I can replace this thing now, this w with this, so I now have 2 pi over t all square r cube over g. And notice this is now the same thing as saying m is equals to 4 pi square over t square r cube g. So for mass of the sun, this will now be the same thing as saying 4 times 22 over 7 all squared, then radius is 1.5 times 10 raised to the power 11 all cube, all over T, and T is 365, shipping. That is time 365, then times 24 hours that happens in 1 hour. That is 3600. So, and it's all squared. Then times G is 6.7 times 10 raised to power minus 11. Yeah, so I'm thinking of that. So this is 1 year. 1 year on Earth, 24 hours every day, 1 hour in seconds. So by the time you do it, you have that the mass of the Earth. Let's punch. So by the time you do this, you have mass of the Earth to be around, mass of the Sun to be around 1.997 times 10 raised to the power 30 kg. So there you have it. So let's move to the next one. So if you remember when we started, we outlined the things we are doing. So the next one is gravity. That is G. So acceleration due to gravity. So let me come back here and do it. So for acceleration due to gravity, which is this one, is simply going to be from mg equals to gm m over r square. I want you to always know that this is the sentence that's saying that force from Newton's law is equals to the mass square, mass of the bigger body and mass of the smaller body, inversely proportional to the distance apart. So if I have this, just cancel this, you now have G is equals to, this is 6.7 times 10 raised to the power minus 11. Then mass of the Earth, we got it to be what? What did we get mass of Earth to be? That should be mass of the Earth that we did now. That should be 6.0 times 10 raised to the power 24. All over. The distance of the Earth is 6.4 times 10 raised to the power 6. So all squared. So let's punch it. So if I do 6.7 times 10 raised to the power minus 11 times 6.0 times 10 raised to power 24, now divided by 6.4 times 10 raised to the power 6 times 6.4 times 10 raised to the power 6. So I don't even know what you watch. Can you even do? Let me do this outside. So you punch this. No, okay. You're getting 9.81 meter per second square. So let's move to the next one. For gravitational potential, using the same approach. For gravitational potential, using the same approach, or gravitational potential is represented with V. Just remember to do the same principle. Just come and do mg equals to g m all over r square. But remember that gravitational potential energy is mgh. And when you do it now, you see that if this is mgh, we replace this one with r. This is now mgr. So we replace this with the edge with r. So it's equals to gmm over r square. So this will cancel this. Then I want to make g subject of the formula. What are you doing, boy? So if the approach I applied earlier was to do this cancelling this, which is not possible. So this should be actually gotten from, I think how I did it best earlier was simply saying gravitational potential energy equals to mg h. But remember that, sorry, let's abandon this, let's use this one. But remember that from here, g is equals to this. G here is equals to gm over r square. So I'll replace it gm over r square. Then times m. Then the edge here, I change it to r, because I'm not talking about height but radius here. So u is equals to this. So by the time I do this, I see that this will cancel this. Then I'm now having u is equals to mgm all over r, which is the same thing as saying gm square all over r. So this is, and this is the same thing as saying maybe mass of Earth and mass of the body. So this is the formula for gravitational potential energy. Another way of doing this is to simply say that gravitational potential energy is simply force that is applied to a body from infinity at a small distance. So because it's applied from infinity is 0 and it tends towards the negative parts. So that is why I have this minus. So we just say that is equals to u. So we'll come and do integral of this. And when another way to do this, so this is or. If I don't do it this way, I do it this way, or. So I can now say, if I'm integrating this now, f will come outside, minus f integral of. Now from this f, sorry, before I do f will come outside, let's do something. I'm doing something with respect, so gmm over r square with respect to r is equals to u. So all the gmm will come as a minus gmm integral r raised to power minus 2, because that's the same thing as 1 over r square. The r equals to u. This will be the same thing as saying gmm, then r raised to power minus 2 plus 1 all over minus 1. So I went to put this first. This should be carrying plus first. So integral of this. So when you do this now, it's equals to u. You've already differentiated with. Please, if you can't remember this one I'm doing, just stick to this. So this is now going to be minus, because of this, divided by this, minus gmm. Then I now have this r that is here is raised to power minus 1 equals to u, which is the same thing as saying, anything that is having raised to power minus 1, this is the same thing as saying minus gmm all over r is equals to u. So it's the same thing here. So this one now, we'll come and put minus here. When we started this, we should have put minus. So this is gravitational potential energy. That is how it's done. Gravitational potential energy from the normal potential energy, you know. When it has to do with gravitational potential energy, you say since you are considering this going up or going around the earth, the g there will be negative. So that is how you do it. I have this. Then carry this thing that I have here now. We'll go back to this. For gravitational potential, we normally say that u is equals to mv. Normally say that U is equals to mv, and that is the same thing as saying V will now be GH. So V is equals to GH. Oh my God. So V is equals to GH. So we say that gravitational potential is simply the work done in bringing a unit mass from infinity, and it doesn't pay attention to the mass. So this is it. So that means this is V equals to, and we know that G is the same thing as saying GM over R square. I told you this H is R. So this will cancel this. So that I have that V is equals to GM over R. So the mistake I made was putting this before this. I should have put this one before this one. So this is how to get it. So if you know that, you can now progress to the next one. So that means we always remember that V is equals to GH. YU, that is gravitational potential, is equals to G. YU is equals to mgh. Or you say, or mv. I'm rushing this video. Escape velocity. When you hear escape velocity, it's simply talking about when kinetic energy is equals to potential, gravitational potential energy. So this is the sentence saying half mv square minus half mv square being equals to, you know that this one is minus mgh. This will cancel this. So this is going to be the sentence saying mv square equals to 2 mg r. Remember that h is r in this case. So now divide by m, divided by m. This will cancel this, so that you now see that this will cancel this. So you now have v square is equals to 2gr. That means take the square root of both sides. V is equals to square root of 2gr. But remember that g is equals to something. So V is equals to 2g. If you remember, g here, g is equals to gm over r square. That is gravitational constant. This one is acceleration due to gravity. So gm over r square, then r. So that means that if you check it, this will cancel this. So V, escape velocity, is also equals to 2gm all over r. So you see that. So it's either V is equals to root 2gr, or V is equals to root 2gm over r. If you like, take the g to be the same. This one is gravitational acceleration due to gravity. This one is gravitational constant. G is equals to 9.81. Why this g is equals to 6.7 times 10 raised to power minus 11. Know the difference. So for orbits around the Earth, let's do it. This one is simply talking about centripetal force is equals to gm m over r square. Everything I'm doing is on the Earth. So you see, it's always all about comparing it to this. And centripetal force is simply mv square over r equals to g m over r square. This can take care of this. That I have, okay, this can also take care of this. That I have v square equals to roots. Sorry, yes. Okay, now it's just right. V square equals to g m over r. And you know that this is the sentence saying root v square equals to root gm over r. This will cancel this. So I'm coming before density of the Earth. So this is the sentence saying from here V is equals to, that is for orbit around the Earth, V is equals to root gm all over r. You need to know that. So root gm all over r. So if I know this, this is the formula for orbits round the earth. And I'm checking something. Since G is equals to C, since G is equals to Gm over R square, does it mean that this can also be GR square all over M is equals to G? So that means that V can also be the same thing as saying here. V can also be the same thing as saying GR square over M. That is for G. Then times M divided by R, which is the same thing as saying V is equals to GR square. Okay. This M can cancel this M. GR square times 1 over R. So remember it's still here. So V is equals to GR square over R. This can cancel this. So V is equals to GR. And remember it's in this. So whichever way. So for orbits around the sun, V can be equals to root GR or root GM over R, depending on how the question comes. I'm rushing it. So now for density of the Earth, I just want to quickly summarize the whole thing. So for density of Earth, we know that that density represented with rho is equals to mass over volume. And Earth is spherical. So from area of a sphere, 4 pi r square, if we integrate plus 1 divided by the new power, this is 4 over 3 pi r cube. So if I come here, volume, that means volume of a sphere is this. Area is 4 pi r square. So if I know this can be the same thing as saying mass of the Earth. Let's check. What did we get as mass of the Earth when we started? I told you I don't cram. And just so for mass of the Earth, GR square over G. So if you remember, that time we started. So GR square over G, that is from mg equals to GMM over R square. Then this cancels this. So you now have so we have it to be GR square over G for the mass divided by 4 over 3 pi r cube. This can be the same thing as saying density equals to GR square over G times 3 over 4 pi r cube. This can cancel this. So I now have density equals to 3G all over 4 pi rg. So density of the Earth is actually 3 times 9.81 all over 4 times 22 over 7. Radius of the Earth is 6.4 times, that is 6,400 kilometers, which is 6.4 times 10 raised to power 6 in meter. Then times gravitational constant is 6.7 times 10 raised to power minus 11 in meter. So punch it. What do you have? Let me check what I got earlier. So if you punch that 10 raised to power minus 11 meter, so if you do it well, you are having 5461.7 kilogram per meter cube. So that's the density. So thank you. Like and subscribe. I'll make a video in class for this. I just had to rush this one.